now a is used to finding the best use of limited resources. So, generally linear programming is one of the classical operation research technique. It is a classical operation research technique. It has yearly used for maintaining applications, but presently it is employed widely for business purposes. Okay, it is now generally used for business purposes. So, in linear programming, we are using the limited resources to maximize or minimize the profits. And generally, the linear programming is basically used in your business industries. So, let us take one example. What are the problems arising? Suppose in a company there are 3 machines, or a cycle manufacturer. In a cycle manufacturing company there are 3 machines. Suppose machine 1, machine 2 and machine 3. And the cycle manufacturer produces 2 kinds of cycles, one for kids and another for youngers. Kids cycle, kids bicycle. Okay, and bicycles. So, the manufacturer produces 2 kinds of cycles. To manufacture the kids cycle or the first kind of cycle, the machine 1 requires 10 minutes. That means the first component of the cycle is completed in 10 minutes in machine 1. Similarly, when the first component is completed, the second component goes to the machine 2 and it will take 15 minutes to complete the action. Similarly, the third component requires 20 minutes to complete the action. Okay? Similarly, the second kind of bicycle require the first part of the bicycle require 5 minutes to complete. 5 minutes to complete. Then the second part requires 10 minutes to complete, and the third part requires 15 minutes to complete. But there is some problem. We cannot run the machine more than 30 minutes. Okay, in machine 2 cannot run more than 45 minutes, and in machine 3 cannot run more than 35 minutes. So these 30 minutes, 45 minutes and 35 minutes are known as constraints or restrictions. That means without 30 minutes the machine cannot run. Okay, these are known as the constraints or restrictions. Similarly, if the manufacturer manufacturing the first kind of bicycle, that is a kids bicycle, and gains a profit of 500, gains a profit of 500. Similarly, the second one, the second kind of bicycle gives the manufacturer 300 profit for each unit. It gives 300 profit for each unit. Then the manufacturer thinks that how I can maximize my profit. Suppose my one unit, if I produces one unit cycle, it gives 500 rupees a profit, and second unit gives 300 rupees profit for the production of a single unit. So let us consider, if the manufacturer produces x1 number of cycles, kit cycle, similarly here x2 number of cycles are produced. So what is the total profit? What is the total profit? That means a single cycle produces 500 rupees profit. So x1 number of cycle produces how much profit? 500 into x1. Similarly, a single unit produces 300 rupees profit. Then next one is your how much profit? That is your 300 x2 number of profits. This is known as a total profit. So this is known as our objective function. This is known as our objective function. Objective function. So in objective function, we have to maximize the profit or minimize. Which one is to maximize or which one is to be minimized? Suppose a businessman or a business firm wants to maximize the profit by using limited resources, limited money. Okay, but he wants to get maximum profit. He wants to minimize the time duration, the money. If the time duration by minimizing the time duration, the money, you will get the maximum profit. So the objective function is to be maximized or minimized. Okay, so we have to formulate the mathematical formula. That means, let us assume for machine 1 requires how much time for the complete of the first part of the cycle? That is your 10x1 plus 5x2. Here the constant, that is your 30 minutes, not greater than 30 minutes. The machine cannot be operated not above 30 minutes. So it is less than equals to what? 30 minutes. Okay, this is known as the inequalities. Okay, similarly 15 x1 plus 10 x2 is less than equals to 45, and 20 x1 plus 15 x2 less than equals to 35. So we can formulate these equations. These equations are called constants. Okay. So next, how to solve a linear program? How to solve a linear programming problem? Suppose in your question, that may be what are the steps? The steps to solve the linear programming problems. Steps to solve a linear programming problems. Steps to solve linear So as you know, in the question, so take one question, that is your maximize z equals to x plus 5y square 5x plus 6y less than equals to 30, 3x plus 2y less than equals to 12, and x y greater than equals to 0. So where the question is maximize z x plus 5. So as you know, the last example I will give you, that is z is our objective function. Z is our objective function, and these are the inequalities are our what restrictions. Inequalities are restrictions. So what are the steps followed to solve these linear programming problems? So first you have to equal the inequalities. Like the first inequalities or constraint or restriction, that is your 5x. This is known as your restrictions. Restrictions. This is known as your objective function. Okay. So first step one. Step one. Equate all the inequalities. Equate all the inequalities. That is 5x plus 6y is equals to 30. So from the question, that is the inequality is less than equals to 30, and here the first step, the inequality is converted into equal. Okay, 30. Then put the value x equals to 0. If you put the value x equals to 0, then you can easily get the value of y. What is the value of y? If you put x equals to 0, then here x equals to 0 plus 6y is equals to 30. Then y equals to 30 by 6, that is the 5. The coordinate that is your 0, 5. The first coordinate or first point, that is your 0, 5. Similarly, here you have to put the value y equals to 0. If you put y equals to 0, then 5x is equal to 30. Then x equals to your 6. The coordinate, that is your 0, 6. So from these inequalities or restrictions, we find two coordinates. That is the first coordinate, that is your 6, 0. We find the first coordinate, that is your 0, 5. The first coordinate, that is your 0, 5, and the second coordinate, that is your 6, 0. That means here x value is 0 and y value is 5. Here x value is 6 and y value is 0. Then solve the second inequalities. Solve the second inequality, that is from here. The second inequality, that is your 3x plus 2y is equals to what? Okay, 3x plus 2y is equals to 12. So as per the step, x equals to, we have to put x equals to 0. After putting x equals to 0, we get y equals to what? 6. Y equals to 6. The first coordinate, the coordinate equals to 0, comma 6. Similarly, if we put y equals to 0, then x value is equals to 4. The coordinate is equals to 4, comma 0. 4, comma 0. Okay. After finding the points, we have to plot a graph. Okay. We have to plot a graph. So we are finding the points, that is 0, comma 6, 4, comma 0, and from the past inequality we are finding the past point 0, comma 5 and 6, comma 0. So after finding these points, we have to plot a graph in your graph paper. Okay. So this is your x coordinate and this is your y coordinate. Okay, so from the graph paper, the maximum value, that is your 6. So this is your 1 unit, 2 unit, 3 unit, 4 unit, 5 unit and 6 unit. Similarly, 1 unit, 2 unit, 3, 4, 5 and 6. So the first coordinate, that is your 0, comma 5, or the first point, that is your 0, this is your origin 0, comma 5, this is your first point. Okay. Second coordinate, that is your 6, comma 0, this coordinate, that is your 6, comma 0. So we have to join these 2 points. Okay. Similarly, in the second inequality, the first coordinate, that is your 0, comma 6, 0, comma 6, 0, comma 6 and 4, comma 0. 0, comma 6, this point, and 4, comma 0, that is this point. Okay. Then after plotting this graph, we have to find the feasible region. What is the feasible region? The feasible region means the common region in between the two lines. In between the two lines, we have to find the common region. Okay. So here the inequality is less than or equals to 0. That means inequality is less than or equals to 0. That means okay. So the graphs are pointing like this because this is less than or equals to 0. So in between the two graphs, which one is the common region? This region is known as the common region. This is common for both the regions. This is common for both the regions. Okay. So you have to then, after finding the feasible region, you have to find out the points or the contact points. This is the first point, this is the second point, and this is the third point. Okay. Okay. So this is your point A, this is your point B, and this is your point C. Okay. So the point A value is, you know, 0, 5. 0, 5. So from the graph paper, we can easily find the value of B point. The value of B point. This is your A point and B point and C point. C point, that is your 4, 0. 4, 0. Okay. what is the value of B point? If you plot in the graph paper, then you can find the value of B point. Okay. So who can say what is the value of B point? B point. What is the value of B point? This is your 3.5 and this is your 2.5. 3.5 or 2.5. Let's assume. Okay, but it is clearly be seen in your graph paper. By plotting in a graph paper, you can easily identify the point B. After identifying all the 3 points, you have to put all the values in the objective function. What is our objective function? That is your z equals to x plus 5y. So you have to first put the value of first a point that is your 0, 5. A point that is your 0, 5. That means you have to put x equals to 0 plus 5y. 5y equals to 5 into 5. 5 into 5. That is your 25. Okay. So in the second, that is your B. In the B point, the value of 3.5 over 2.5. Okay. You have to put the value of z. Z equals to x equals to your 3.5 plus 5 into 2.5. 5 into 2.5. What is the value of this? 3.5. 12.5. Okay. The answer will be 16. Okay. And the third point, that is your C point. C point the coordinate as 4, 0. So you have to put z equals to x plus 5y. The value of x here, that is your 4 plus 5 into 0, that is your 4. So by putting all the points, which value is maximum? Which value is maximum? This value is maximum. At point A, the value is maximum. At point A, the value is maximum. Our objective is to maximize the profit, that maximize z. That means by putting all the 3 values, we are getting the maximum value at point A. That means the answer is 25. That means the seller or the company gets maximum profit at a point. Okay. So this is the steps how to solve your linear programming problems. First one, find the objective function, find the restrictions, then the restrictions are in inequalities, then convert the inequalities equal signs. After getting the equal, then put the value of x, find the value of x and y. Okay. After finding the value of x and y, put the value, then plot the graph in your graph paper, then find the feasible region. After finding the feasible region, then find the coordinates of the feasible region. And after finding the coordinates of the feasible region, you have to put the coordinates into your objective function. Then finally, if the question asks you to maximize the function, what is the maximum value, you will get the answer. What is the minimum? If the question asks you minimize the function, if the value is minimized or the minimum value comes, that is the answer. Okay, thank you.